Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, the Science and Technology channel.
Yeah, and we were talking about our mutual favorite topic again. It's been a while, but we're going to talk about space, the final frontier today. So, and yes, particularly about the red planet, right? Is not Mars the red planet? Yeah.
Yeah, new discovery there.
Yeah, and it's happening all the time, right? We're having new discoveries about animals and insects and creatures and also up in space. So, very cool.
And manuscripts and mummies.
Yeah, we just talked about that a day or two ago. So, yeah, absolutely.
Curiosity just found molecules on Mars tied to the chemistry of life, hinting at a more habitable past. NASA's Curiosity rover has discovered a wide variety of organic molecules on Mars, including compounds often viewed as essential ingredients for the origin of life on Earth. These results come from a chemical experiment carried out on another planet for the first time. The findings show that the Martian surface can preserve molecules that might serve as indicators of ancient life. However, the experiment cannot determine whether these organic compounds formed from past life on Mars, natural geological activity, or arrived via meteorites. Would you like to know more?
To confirm any true signs of past life, scientists would need to return Martian rock samples to Earth for more detailed analysis. Okay, so we haven't quite figured that out yet, right?
Right.
The search was led by Amy Williams, PhD, a professor of geological sciences at the University of Florida, and a member of the Curiosity and Perseverance rover science teams. Curiosity landed on Mars in 2012. It doesn't seem like it was that long ago. That's amazing. To investigate whether the planet once had conditions suitable for microbial life billions of years ago.
Perseverance, which arrived in 2021, is focused on searching for direct evidence of ancient life. Quote, "We think we're looking at organic matter that's been preserved on Mars for 3.5 billion years," said Williams, who helped develop the experiment. "It's really useful to have evidence that ancient organic matter is preserved because that is a way to assess the habitability of an environment. And if we want to search for evidence of life in the form of preserved organic carbon, this demonstrates its possibility."
Maybe I'm confusing Curiosity with Perseverance, because I know that, again, that was just about 4 or 5 years ago. So
yeah,
maybe that's what I'm thinking of. So, okay. Williams and an international team of researchers published the study April 21st in the journal Nature Communications on April 21st in 2026. The experiment identified more than 20 different chemicals. Among them was a nitrogen-containing molecule with a structure similar to compounds involved in building DNA, something never before detected on Mars. The rover also found benzothiophene, a large sulfur-containing compound with a double-ring structure that is commonly delivered to planets by meteorites. Interesting.
Quote, "The same stuff that rained down on Mars from meteorites is what rained down on Earth, and it probably provided the building blocks for life as we know it on our planet," Williams said. Curiosity, managed by NASA's Jet Propulsion Laboratory, landed in Gale Crater in August 2012. This location was once a lake bed. The experiment took place in 2020 in the Glen Torridon region, an area rich in clay minerals that formed in the presence of water. These clays are particularly effective at trapping and preserving organic molecules, making them an ideal target for this type of research.
Work was carried out using the sample analysis at Mars Instrument Suite, known as SAM, S-A-M. Jennifer Eigenbrode, PhD and an astrobiologist at NASA's Goddard Space Flight Center and author of the study, helps lead the SAM team. The instrument has played a central role in many Curiosity's discoveries related to Mars chemistry, atmosphere, and potential habitability.
For this experiment, scientists used a chemical called TMAH to break down larger organic molecules into smaller components that could be examined by SAM's onboard instruments. Because Curiosity carries only about 2 cups of TMAH, The team had to carefully plan the experiment and select the most promising sampling site.
The success of this approach is influencing upcoming missions. Future projects, including the Rosalind Franklin mission to Mars and the Dragonfly mission to Saturn's moon, Titan, are expected to include similar TMAH-based experiments to search for organic compounds. Very cool.
Quote, we now know that there are big, complex organics preserved in the shallow subsurface of Mars, and that holds a lot of promise for preserving large, complex organics that might be diagnostic of life, Williams said.
Yeah, so the other day I was talking with somebody, just in general, and the space program came up as far as the topic of the conversation started out that I heard was it was a waste of money. And I thought to myself, man, you're missing the boat here. We're getting to the space faster, more efficient. We're using reusable rockets, right? Thanks to SpaceX. And all of a sudden now you're making a statement that you just don't think it's practical to do that. And I thought to myself, man, I'm glad they were not around in the 50s and the 60s when the rocket testing.
Was penicillin a waste of time and money?
Yeah,
was
I don't
aspirin?
know. I don't know, but the fact that, when the space program was just starting, when they were just doing rocket testing, not too far from here, right? Out of El Mirage. Or what's the name of not El Mirage.
China Lake?
No, the name of the
Edward?
It's where they were landing the shuttle for a while. Oh gosh, I can't think of it. Anyway, my dad worked on some of those rocket test sites out there. And what did somebody had said? And I'm sure there were people back there saying, hey, this is a waste of time. We just don't need to do this. But I'm glad they didn't, and I'm glad we're not doing it now. I'm glad we're continuing on with it. I mean, maybe not even for my grandkids to get benefit from, but maybe their kids or their grandkids will be able to see some kind of benefit from exploring these planets. And again, we're going back to the moon in a couple of years, according to our president. And, Mars is just around the corner, I think. I think it is. So not a waste of time, not a waste of money. It's a good investment. So here we go.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
Take care, everyone. Thanks for listening.